Okay, first of all, let's remind ourselves of our order of operations. So our order of operations is PEMDAS. Please excuse my dear Aunt Sally. And that's the order that we complete equations in. So we go in this order. And then just like wrapping a present and then unwrapping a present, if we want to solve, if we want to undo an equation, we have to go in reverse order. So if we want to undo, if we want to solve, we have to go in reverse order. So just like you have to take off your shoes before you take off your socks, you have to work backwards when you're solving. Now remember, addition and subtraction go together from left to right. So they're on the same level, the same step. Multiplication and division go together from left to right, same step, same level. So on problem number 1, we do have some addition and subtraction to deal with. We want to get x by itself on this problem. So we are going to add 3y to both sides of our equation. So we have 2x is equal to 9 plus 3y. But we want x by itself. So we have to ask ourselves, what is happening to x right now? Right now, x is being multiplied by 2. And the opposite of multiplication is division. So we need to divide both sides of our equation by 2. When we do this, these 2's cancel out. So now we have x equals 9 divided by 2 is not a whole number, so I can leave this as 9 plus 3y over 2. Now remember, we could not combine the 9 and the 3y because they're not like terms. If you want to use a decimal, as long as it's a terminating decimal, meaning it ends, you can do that. So 9 divided by 2 is 4.5, plus 3 divided by 2 is 1.5. Don't forget your y. So I would accept either one of these answers. You need to circle your final answer. Make sure I see all your steps on every problem. All right, on problem number 2, we have the same equation as number 1, but this time we need to solve for y instead of solving for x. So the very first thing I'm going to do is look and see if I have any addition and subtraction to undo, and I do. So I'm going to subtract 2x from each side of my equation. Now I have a negative 3y is equal to 9 minus 2x. Okay, I don't have any more addition or subtraction to get rid of. So I've got to say, what is still keeping my y so that it's not by itself? Well, that negative 3. What is that negative 3 doing to my y? It's multiplying by my y. So the opposite of multiplication is division. I'm going to divide both sides of my equation by negative 3. So these cancel out. So I'm left with y equals 9 minus 2x all over negative 3. Now, if you wanted to write this out, slightly differently, you could say 9 divided by negative 3 is negative 3. A negative divided by a negative. So take a look at what we're doing. We're dividing each piece by that negative 3. So negative 2 divided by negative 3 would give me a positive 2/3 times x. So once again, I would accept either one of these two answers. Okay, problem number 3 asks us to solve for y again. In this problem, we have 5x plus 3y equals 15. So the first thing we ask ourselves, do we have any addition or subtraction to get rid of? And we do. So we want to get the y by itself. So the easiest thing to get rid of is that positive 5x. So we're going to subtract 5x from each side of our equation. So we now have 3y is equal to 15 minus 5x. Okay. Ask yourself, what is happening to y right now? It is being multiplied by the number 3. So in order to undo that multiplication, we need to divide both sides of our equation by 3. These 3's cancel out. So we have y equals, now we could leave this as a fraction, 15 minus 5x all over 3. Or just like the previous problems, we could split up each piece. So 15 divided by 3 is the number 5 minus 5 over 3. That decimal does not end, so we're not going to leave it as a decimal. And don't forget your x. X can go out to the side or it can go up with the 5, but it cannot go down with the 3. I would accept either one of these two answers. They are equivalent to one another. So it's just like giving me a dollar bill versus giving me a quarter. Still giving me the same value. Okay, problem number 4 asks us to solve for m. Okay, we want to get m by itself. So the easiest thing to get rid of is that negative 1. So I'm going to add 1 to each side of my equation. So now I have 4n plus 1 is equal to 3m. Well, now I want to divide by 3 because I have 3 m's and I only want 1 m. That 3 is multiplying by the m, so to undo that multiplication, I need to divide. These 3's cancel out. This is very similar to the problems that we've just done in 1 through 3. We have m equals 4n plus 1 over 3. Now, this would not divide out well, so I highly recommend leaving it like this. If you really want to split it up, we do know that if we're dividing, we can split it up. So you could write it out as m equals 4/3 n plus 1/3. That would be equivalent. I would accept either answer here. Remember, I need to see all your steps as you move along. Okay, problem number 5 asks us to solve for w. We have 2w plus 2l equals p. So this is the equation for the perimeter of a rectangle. 2 widths plus 2 lengths equals the perimeter of the rectangle. So the first thing that we're going to need to do is get rid of the addition and subtraction. We want to get w by itself, so we need to get rid of this 2l. So it's a positive 2l, so I'm going to subtract 2l. Again, we use the cursive since a non-cursive L looks like a 1. We use the cursive so that we're clear that it is a variable and not a number. Okay, so now we have 2w is equal to p minus 2l. But we don't want 2 w's, we want just w. So that 2 is multiplying by the w. Now we're going to divide by 2 because dividing by something undoes multiplication. So these 2's cancel out. We're left with w is equal to p minus 2l over 2. Now you may notice that we have a 2 on top and a 2 on bottom. So you definitely might want to split this one up. Each piece of the numerator has to be divided by the denominator. So we have W is equal to P divided by 2. We can't simplify that any, so we're just going to leave it as P over 2 minus the 2 divided by 2 does cancel out, so it would just be minus L. I would accept either of these answers. Although in this case, the bottom actually is preferable because we do get to cancel out the 2's. In the previous problems, one of them isn't necessarily better than the others. In the previous problems, the fraction is likely a better choice. Okay, on problem number 6, we need A by itself. So we have 2A plus B equals C. So the first thing we're going to do is subtract the B. So now we have 2A is equal to C minus B. Well, we need A by itself. Right now, A is being multiplied by 2. So the opposite of multiplication is division. We're going to divide both sides by 2. These 2's cancel out. So we're left with A is equal to C minus B over 2. There's really no point in splitting this one up. We don't simplify anything, so let's just leave it as a fraction on this one. Okay, problem number 7 has come up several times at this point, and I know that there's still some confusion about this. So I want to try a practice problem off to the side first to try to make a point. So let's say we had a problem that read 5 is equal to 10 divided by R. And we need to get R by itself. Okay, in this problem, we can clearly see that we cannot get R by itself in one step. It's simply not possible because R is in the denominator and we need R by itself. In order to get R by itself, it has to be in the numerator alone. So the first thing we have to do in this problem, there's just no other choice. We have to multiply both sides by R. There's nothing else we could do. Now that we have R times 5, or 5R, same thing, is equal to 10. Because these canceled out. Okay, so we still want R by itself. The R is being multiplied by 5. So now we're just going to divide each side by 5. The 5's cancel out. So we have R is equal to 10 divided by 5. And we could even go one step further. R is clearly the number 2 in this case. Okay, so don't get freaked out just because you have variables instead of numbers. In this equation, we have I is equal to E divided by R. Well, it's the same process that we just went through. R needs to be by itself. R is not currently by itself. There's no way to get R by itself unless we first multiply both sides of the equation by R. We just don't have any other options because we have to get it out of the denominator. So now we have R times I is equal to E because these R's canceled out. Well, now it's a very simple problem. We want R by itself. R is being multiplied by I. So the opposite of multiplication is division. So I'm going to divide both sides by I. These I's cancel out. And we're left with R is equal to E divided by I. It's the same process. The place where we had the E is the place where we had the 10. E and 10 ended up on top. The place where we had the R is the same place we had the R. They ended up in the same position. The place where we had the I is where we had the 5. They end up in the same position. Don't get freaked out just because you have letters instead of numbers. Just follow the rules of solving an equation. Work PEMDAS backwards. Okay, problem number 8. Now there's different ways that you can look at this problem. The first thing I'm going to look at and say, okay, I do have some addition and subtraction. That's the easiest thing to get rid of. So the first thing I'm going to do is subtract that 1 because we want x by itself. So now I have y minus 1 equals 1/4 x. Well, that 1/4 is multiplied by the x. So we could undo that by dividing by 1/4. That's one way to do this. Or we could look at it and say that that's the same thing as saying y minus 1 is equal to x divided by 4. Multiplying by a 4th is exactly the same as dividing by the number 4. To me, that makes this problem a lot easier. Because if I'm dividing by the number 4, then I clearly understand that in order to undo that, I need to multiply both sides of my equation by the number 4. Now, I have to be careful here. I have to multiply the entire side by 4. So I have to distribute that 4. Okay? Now, these 4's over here cancel out. So I'm going to write this final answer 2 ways. I'm going to write it out as x equals 4 times the quantity y minus 1. And then I'm going to go ahead and write out what that would be if I distributed. So x equals 4 times y is 4y. 4 times negative 1 is negative 4. I would accept either one of these answers. I would accept either one of those answers. They're both correct. Okay, now on the back of your paper, you have to be really careful to answer the question that they ask. In problem number 9, they simply ask you to solve for b squared. A lot of people tried to make this problem harder than what it was. We only need b squared by itself. So what's happening to b squared right now? It's being added to a squared. Well, that's easy to undo. We're going to subtract a squared from each side of the equation. So we have c squared minus a squared is equal to b squared. Do we have b squared by itself? We do. B squared is by itself now, so we're done. This is all we needed to do in this problem. That's it. Okay, on problem number 10, it asks us to solve for s. So the volume is s cubed. This would be the volume of a cube. Okay, so if you have the side length of a cube, then you're going to cube that to get the volume of the cube. So how much sugar is in a sugar cube? Take the length of a side and cube it. So 5 times 5 times 5. If the length of a side of a sugar cube was 5 centimeters, then you have 125 cubic centimeters of sugar in that cube. Now, let's figure out how to undo it. If we have a square, we undo that with a square root. If we have a cube, we just need to use the equivalent root. So I'm first going to rewrite this with just a little bit more space. We literally just want to undo a cube. So instead of a square root, we have to cube root each side. So we need the third root, the cube root. So that means our final answer is the third root, or the cube root, same thing, of the volume is equal to the length of a side. Because by definition, the cube root of a cube is the thing itself. It's like saying the square root of 5 squared. So 5 squared is 25, and the square root of 25 is 5. You're undoing it. Cube root of something cubed, you're just undoing each other, so you're just left with s. So So this is your final answer on number 10. Problem 11 asks us to solve for r squared. So once again, make sure that you're answering the question that it asks you. Okay, what's happening to r squared? It's being multiplied by several things. It's being multiplied by 4, and it's being multiplied by pi. This is the surface area of a sphere. So how much rubber does it take to make the outside of a basketball? Something like that. Surface area, just the outside. Not the inside, not the volume, just the outside. Okay, so we undo multiplication with division. We can do this at the same time. You could do it in multiple steps. It's not wrong to do it in multiple steps, but there's no reason why we have to do it in more than one step. The 4's cancel, the pi's cancel. So we're left with s divided by 4 pi is equal to r squared. And that's it. There's nothing else we can do here. There's no other answer that would be acceptable on this one. S divided by 4 pi is equal to r squared. Be careful that your pi looks like the pi symbol. All right, on number 12, it asks us to solve for a. Okay, well, we've got a plus b plus c all divided by 3 is equal to m. So we're going to have to get rid of that divided by 3 first. We can't get to the a until we get rid of that. So the opposite of division is multiplication, so we're going to multiply both sides by 3. So we have 3m is equal to a plus b plus c. Well, now it's a super easy problem. See, because these 3's canceled. Now we're just dealing with addition. Addition's very easy to get rid of. The opposite of addition is subtraction. So I need to get a by itself, so I need to subtract the b. So I've got 3m minus b is equal to a plus c. I need to get rid of the c, so minus c. So I got 3m minus b minus c is equal to a. Now, I would accept it if you had the minus c followed by the minus b, but generally speaking, it's good practice to go in alphabetical order. So, here's our final answer on problem 12. Okay, problem 13 asks us to solve for a. And we have another one of those pesky cubes in here, but we know how to deal with that now. So we're okay. The first thing we need to get rid of is that plus b. So the opposite of plus b would be minus b. So we have a cubed is equal to c squared minus b. Well, we need to get a by itself. We have a cubed. How do we undo a cube? That's right, we cube root it, just like we did on problem number 10. So, by definition, what is the cube root of a cubed? You're right, it's just the letter a. That's the whole reason why we took the cube root of a cubed. Now, this is c squared. We can't simplify that because we're taking the cube root of c squared. C is not cubed, so we just have to leave it. So it's the cube root of c squared minus b. That's it. That's our final answer. I don't know of any other version that would be correct in this one. So that's our final answer. Okay, problem 14. Force divided by acceleration equals mass. F divided by a equals m. This is an equation that you use in science. You'll continue to use it in science. In this case, we want to solve for acceleration. That happens. Sometimes you need to solve for force. Sometimes you need to solve for mass. Sometimes you need to solve for acceleration. It all depends on the problem and context. So if we're going to solve for a, think back. This has things in common with problem number 7 from before. We can't do this in one step. A is in the denominator. So first we have to get it out of the denominator, because right now we're dividing by a, and we need a to be by itself. So the very first thing we're going to have to do is multiply both sides by a. We have to do that just to get a out of the denominator. So we have force is equal to mass times acceleration. That's probably the formula that you're used to in science. But again, in this case, we want to solve for the a. Well, it's really easy now because we know that the mass is being multiplied by the acceleration, and the opposite of multiplication is division. So we're going to divide both sides by m in order to get a by itself. So I divided by m. And now I have force divided by mass equals the acceleration. There's no other way that this one would be correct. I mean, technically you could have a equals f over m. You could have the a on the other side as long as you had the f over m on the other side. But other than that, this is the only version of this equation that would be correct. Okay, we're almost done with this problem, these type of problems. So we're on 15. Now, in this problem, we need to solve for B1. This one's a little more complicated. We're dealing with some multiplication, some addition, some parentheses even. So let's see. We can't undo the addition right now because they're inside parentheses. So we've got to wait there. We do have this times a half. Personally, it's much easier for me to think of dividing by 2 instead of multiplying by a half. They're the same thing, remember? So let's say you have $10. If you multiply that by a half, so a half of $10 is $5. Well, that's exactly the same as if we divided $10 by 2. So I'm going to rewrite the problem just like this. And the reason why I rewrote it is because now it's a lot easier to see what I need to do in order to undo that times a half. So the times a half is exactly the same as dividing by 2. And it's really easy to undo dividing by 2. We just multiply both sides by the number 2. So now these cancel out. We technically could have divided by a half. That does the same thing, but it's a little harder to think about. Why does dividing by a half give me 2 a's? Because there are 2 halves in a whole a. So now I'm left with h is equal to b1 plus b2. Okay, so I still need b1 by itself. So it's multiplied by h. I'm going to undo that multiplication. So I'm going to divide both sides by h. So now I have 2a over h is equal to b1 plus b2. Nothing else is being multiplied by that, so there's no reason to write the parentheses now because there's nothing happening on the outside of the parentheses anymore. We're just left with the b1 plus b2. So now this becomes a lot easier. In order to undo addition, we just subtract. So we're going to subtract b2. So our final answer here, it took a few steps, but as long as you follow each step, it's really not that bad. We've got 2a divided by h, then minus b2. And that equals b1. So just to give you a heads up, this is the equation for the area of a trapezoid. And there are definitely times in geometry where you will have to solve for one of the bases in the problem. So this is very helpful that you're able to rearrange the equation so that you can solve for different pieces of the trapezoid. Okay, on 16, we want to solve for h. So we've got 1/3 r squared h. Well, once again, it's a lot easier for me to rewrite this as r squared times h all over 3. Because multiplying by a third is the same as dividing by 3. So now it's really clear that I need to multiply both sides of my equation by the number 3. So if I multiply by 3, I have 3v is equal to r squared h. I need to solve for h. So the next thing I need to do is figure out what's happening to h. Right now, h is being multiplied by r squared. So I undo multiplication with division. So I need to divide both sides of my equation by r squared. So the r squareds cancel out. We're left with h is equal to 3v divided by r squared. And that's your final answer on the final problem.